Okay. Okay. Let me make a slide here. Okay, let me make one slide here. Okay. Okay, so what I started to explain last lecture is, given a truth table, okay, how can you get a function, okay? So what I did before, I give you the function f equal a and b or whatever. So I give you a function and then you can create truth table. Now I want to do the opposite. Given a truth table, how can you get the function from the truth table, okay? For example, I'm going to assume I have a truth table, something like that. You have here 3 variables. We have here f or f of x, y, z. So I have 3 variables here. So the truth table is x, y, z. And then, as you know, the way you have to do the truth table is it has to be 0, 1 for sure, because it's 3 variables. So how many entries, how many rows I should have? I should have 8 rows. Okay. So 0, 1, 0, 1, 0, 1, 8 times. And then for y, it's going to be double zeros, double ones, and then double zeros. For x, it's going to be half of what we have here is zeros. Sorry, I think something is wrong. 2, I think we still have one more here. Okay. And here we have 1, 1. Okay. 4 zeros, 4 ones. Is that okay? So these are all possible cases for x, y, z. Is that okay, guys? Let's agree on something very important. It's gonna make confusion for you in the future, but let's agree on it right now. When I tell you I have x, y, z, okay? So that means in the whole course we're gonna follow this way, because if you don't follow it, we're gonna make confusion. Okay, it's not gonna be true. Okay, so listen to me. When I say x, y, z, I mean z is the least significant bit. Okay. So you can see 0, 1, 0, 1, 0, and x is the most significant bit. Same thing if I tell you my function is ABC. Okay, so what we're going to do, that means this one is the least significant and this one is the most significant here. Okay, because if you change it, it's going to make it's going to make trouble for us, as I'm going to explain anyway. Okay, so let's agree on that. So this is the truth table, and then I told you I have a function. For example, I have here f. This f. So when this is the input of the function, okay, so this function is gonna give me 1, and if this is the input, the function gives me 0. Here I just put some random things, okay. So here 0, and then here we have 1, for example, and then we have here 0, 1, 0, 0, for example. Okay, so I have a function. When I input, this is the input, this is the output. This is the input, this is the output, and so on. Is that okay? So that means if you look at the logic circuit here, the logic circuit simply, it has 3 inputs, which are x, y, z, the 3 inputs, and it has only 1 output. I call it f. Is that okay? By the way, because this is something you are going to see in the homework, and this is also something you are going to see in the future. Until now, just to make it easy, all the truth tables we have, I assume that the output is only 1 bit. Is that okay? That's what I did so far. However, that doesn't mean it's always the output is going to be 1 bit. Sometimes the output is actually 2 bits and so on, or maybe 3, whatever it is. Okay, so just so in this case, for example, here you are going to have this is for 1 bit, so I'm going to have another column here for the other bit. For example, it can be 0, 1, 1, 0, 1, 0, 1, and so on. Okay, and in this case, you need 2 equations. You need equation for this one, and you need another equation for this one. You understand what I'm saying? So you need 2 equations. So what I'm explaining right now, what I'm going to explain in only one, if the output is only 1 bit, okay, I need only 1 equation. Okay, I'm going to explain how can you get it. But if the output is 2 bits, it's the same thing, but you have to repeat what I'm going to explain right now twice. 1 time here and 1 time here. So this one is going to give you equation. This one is going to give you another equation. Okay. Anyway, so there is no difference. It's going to be exactly the same thing, but you are going to double the work. Okay. Anyway, so I just want to bring this to your attention. Yes, all the time here, I just assume the output is 1 bit, but in reality, it can be 2, okay, or maybe more. If you do addition, if I add 2 bits to 2 bits, the output can be 3 bits. The output is 3, okay, and so on. But if the output is going to say yes or no, for example, I want to see if the input is a prime number or not. Okay, so the output should be yes or no. So it's going to be, in this case, has to be only 1 bit to tell me yes or no, okay, and so on. Anyway, so let's return to my point. My point here is given this is a question. That's what I want to answer right now. Given this truth table, how can you get the function? Okay, what do you mean by get the function? So I want to get f, for example, equal whatever. I'm going to put any random thing, is xy or x prime y, for example. Okay, any random things. So I need to get this one. What I did so far, I give you this one, and from this one, can you get the truth table? Now I want to do the opposite. Okay. So to do that, there are 2 ways, or not 2 ways, two format or 2 forms for this function. One is called sum of product. The other one is called product of sum. So what I'm going to explain right now is, given this truth table, how can you get the function in this format, and also how can you get the function in this format? Okay, that's what I'm going to explain right now. After that, I'm going to tell you why we have two formats. Is there a reason for that? I'm going to tell you why. Okay, and by the way, also there is one slide in here in the slide 25. I prove to you these 2 formats, they are equivalent, give you the same results. So because just you represent the function in 2 different ways, but they are equivalent. They give the same result, but just in 2 different ways. But anyway, so this is what I'm going to explain. So let's start one by one. So in the beginning, I'm going to start with sum of product. Okay. So what do you mean the format, or you're going to be in the form of sum of product? What sum and what product? Okay, I told you last time that term we are using somehow confusing. We don't have sum, we don't have product. So what I mean here by sum, okay, sum here means or. Product here because it's plus, and the plus usually use it for sum, so that's why they use. I don't have any other. I don't know why they call it sum of product of sum, but this is the meaning of it. So sum here means or, product here means and. Okay. So this is the format. So, and this is how it looks like actually. So number one, we have or. We have or this way. Okay. And then we have here one term, another term, this way. And every term here, okay, every term, this is sum of product, okay? So every term here can be only one variable, or can be one variable or multiple variables, but these variables are and multiplied by together, so and, okay? So this is how the format of it. So we have here one term. This term, for example, it can be x, y prime z. So here we use and here. So that's why you call it sum of product, because this is product, and then I do sum here. That's the meaning of it. Or I'm gonna do or for and. Anyway, so the question is, given this one here, given this truth table, how I can get f this way? Okay, I'm gonna tell you how. Number one. In this case, I'm gonna work on the ones, not zeros. I don't care about zeros. I'm gonna work only on ones. That means, and look here how many ones I have here. Let me use a different color. So I have one here, I have one here, I have one here. Everyone is gonna make one term here. Everyone is gonna make one term here. So in this case, I have 3 terms. In every term I use and then I connect everything using or. That's why it's called sum of product. Okay. Okay. So everyone here is going to create a term. So actually, so now I have here, I'm going to call it term 1, term 2, term 3. So actually, F should equal term 1 or term 2 or term 3. And every term here is going to be product end. Is that okay? This format is called sum of product. We have product, and then I sum or I OR them together. So now the question is how I'm going to hit term one, and that's it. Again, number one, we're going to work on the ones. I don't care about the zeros. For everyone, I'm going to create one term, and this term I'm going to, after that, I'm going to, for everyone, I'm going to create one term using and. Then I'm going to OR everything together, and that's it. That's what we call sum of product. Is that okay? Okay. I don't want you only to know the method. Also, I want you to understand, not only know the method or memorize the method. Understand what is the logic. How you did it this way. I'm going to tell you what is the logic. Look here. You know, this is OR. In order to get one here, at least one term here should be one. We agree on that, right? In order to get one, at least one term should be one. Okay? So what I'm going to do is, when I create this term, I'm going to create this term so that this term is going to give me one for this input. Otherwise, for anything else, it's going to give me zero. So when this input comes, this term will give me one. And then for any other input, this term is going to give me zero, right? For this one, it's the same thing. When I create this term here, I'm going to create it so that for this specific input, this term is going to give me one. For anything else, it's going to give me zero, right? Same thing for this one, right? So now, very simple. I have three terms. These three terms are ORed together, When this input comes, this one, 0, 0, and I get one. When this input comes, it's going to be one here, 0, 0, and I get one. This is the logic behind it. So same thing here. For this one here, this one is 1, and this one is 0. What about for anything else? For anything else, the three terms are going to give you other than this one. Anything else, you're going to get 0, 0, 0, and because 0 or 0 or 0 is 0. Any questions? So now the question is, how I can create a term here so that when this input comes, this term is going to give me 1, and they're going to give me 0 anywhere else for any other input. Okay, I'm going to tell you how. Look how it works, and then think about it. Here, for sure, I have to use AND. We agree on that because this is sum of products, so I have to use AND. So in this specific case, in order to get one here, in this specific case, what should be the input? Okay, the input here, because this is AND, in order to get one, all the input should be ones. Okay, that's why it has to be X prime, Y prime, Z prime. X prime, Y prime, Z prime. Okay, so that when 0, 0, 0 comes, I'm gonna have here 1, 1, 1, and then I get 1. For any other input, I'm not gonna get 1, 1, 1. I'm gonna get, there should be at least 1, 0 here, 1, 0 to produce 0. So if you do this way, I'm gonna get only 1. This term is gonna give me only 1 in this specific case. Any other case is gonna give me 0, and that's exactly what I want to do. Okay, so let's think about this one here. So this is what term I have to use here. Very simple, because here I'm using AND to get 1. All inputs should be ones, because these ones are ones. So I'm gonna say here, I'm gonna use them without complement. Okay, but this one has to be complement. So this is the way you have to do it. Any 0, you need to complement the variable. Any 1, just keep it so that the input of the AND is 1, 1, 1, 1, and then I get 1. So that's why here it's actually X prime, Y, Z. This is the second term. For this term, okay, so for this term, it's actually X, Y prime, Z. Okay, so let me clear everything here. So by this way, So anyway, I explained the logic behind it, why we made it this way. I don't want to just memorize. I can just explain to you how to do it, okay? But no, I want to also not only you should not only have to do it, but why we made it this way. Okay? So now I can say my function is, let's take the first one here, is gonna everyone is gonna contribute by one term, as I told you, x prime, y prime, z prime, or here, this one here, which is x prime, y, z, or x, y prime, z. That's it. Any questions? Is that okay? Very easy, right? So now I'm gonna give you one more example of whatever, but now I'm expecting if I give you a truth table, you should be able to calculate the function using sum of product. Is that okay? Let's see one more example here. For example, this one here, again, we have A, B, C, as I told you. Now I want to calculate the function in sum of product, as I told you. So again, number one, you have to work only on ones, not zeros, okay? And then, so now how many ones I have here? 1, 2, 3, 4, 5. That means I have 5 terms. For every one, I have 1 term here for everyone. All of them are ordered together. So how can you get these terms here? How can you get these terms here? So that this term should give me 1. In this specific case, anywhere else should give me 0. Okay. So I told you the way you have to do it here. If you have here 0, so you have to use the complement A prime. Here for 1, you have to use B and C. Okay. So this one is equivalent here. Same thing here. For any 0, you have to use the complement because this is AND. In order to get 1 out of n, all input should be 1s. So any 1, I'm going to keep it without complement. Any 0, I need to complement the variable. Okay. Same thing here. So for this one here, as we see, A, B prime, C prime. For this one here, A, B prime, C. For this one, A, B, C prime. This one is ABC. Any questions? Okay. Don't be confused. In these small things, I give you example with 3 variables. Please, that doesn't mean this approach can only work for 3 variables. It's not true. This approach can work if the input is 2 variables, if it is 5 or 6 or whatever, or 4, whatever. But just I give you example for 3. Any questions? Okay. One more thing I want to tell you here is these terms, I call them terms, but actually we call them min terms. So everyone here, we call them min terms. Okay. So these ones here, or these terms, we call them min terms. Okay. Also, look here. What is the number here? This is number 0, row 0. So if you convert every number here, okay, to binary, so this is 0. This is row number 1, because remember 1, 2, 4. Okay. This is row number 2, row number 3, row number 4, number 5, 6, 7. Is that okay? So now I want to tell you something also. Okay. Anyway, so again, you understand what I did. Number 1, I took only the ones. Okay. Number 2, I created these terms, and I told you these terms will call it main terms. This is the expression we're going to use all the time. And I want to teach here something somehow new. So now I can represent the function. I can give you a function using the min terms. For example, I can tell you the function is actually have this min term. The min term at 3, the min term at 5, at 6, 5, 6, 7. So the way we do it, I can tell you F equal summation of M0 sorry, M3, okay, M4, or sometimes we just write 3, 4, 5, 6, 7, okay, or M3, M4, M5, M6, M7, okay. So this is another way to express the function. So if I want to give you function, now we have 3 ways. One way, I can give you this equation this way. This is one way. Second way, I can give you a truth table like this one. Third way, I can tell you about the location of the ones. Okay, this way, I can tell you. So this function, for example, here in this specific function, I can say, this is what we call, I can represent the function using min terms. Min terms. So here I can say f equals summation of, this is here, I look at the ones, the location of the ones. So we have here ones starting from number 3 until 7. So 3, 4, 5, 6, 7. That's it. So this is a function. So now I can represent the function this way. I can represent it this way. I can also represent using truth table. This is another approach. Is that okay? So here, this is the location of the ones. So the other numbers that are missing here are the location of zeros. You understand what I'm saying? So here we have ones at number 3, number 4, number 6, row number 3, row number 4, 5, 6, 7. That means the other ones, because we have here rows from 0 until 7, the other one should be 0. Is that okay? If I do the same thing, if I go back here in this example, yeah, in this example, okay, I can say here the function equals the summation of, okay, here we have at 0, this is number 0, okay, comma, here we have here number 3, 110 is 3, comma, also we have here which is number 5. Okay, so if I give you something like that, this is enough to define a function. That's enough to define a function. Okay, the missing numbers are zeros. Yes, that's your question.
How would you?
I don't know. That's a very good question. Very good question. That's a very good question. It's my fault. I'm lazy. Okay. So what you are saying, if I say if equal whatever, yeah, how many variables? Because you have until 5. Until 5, that means 2 variables, no, can't. Because 2 variables, you are going to have number from 0 to 3, not 5. So I can have this, it can work for 3, it can work 4, 5, 6, 7, 10, 1 billion, 1 trillion. It can work for any number of variables. Is that okay? That's why, to be more accurate, actually, I have to say f of x, y, z. Thanks, man. Okay? Or I have to tell you f, a, b, c. So I have to tell you how many variables. It's not something you can guess. But I'm just lazy. I say f because I already told you x, y, z, but this is the right way to write. Any questions? Okay, now. So this is the first format we have. We call it sum of product. Is that okay? Let's have the other format I have. Let me remove everything. The other one, we call it product of sum. Product of sum. What it means? It means we have here and, because this and here is product, and then we have here or. Several ors. Several or. Is that okay? This is the other format. I told you we have 2 formats. The 2 formats are going to give you exactly 2 different, okay, 2 different representations to the function, but they are equivalent. They give you the same result, but they look different. Okay. And also, I told you we need to know later. I'm gonna explain why we have 2 formats. Why it's not only one? Just use it. For sure, there is a reason. But let me first finish what I mean here. Okay. So how can we do it? Okay, let's have here the same example we had before, x, y, z, and then here we have again, please, this is the least significant, okay? Because if you change it, everything may change. It will change. You are gonna make trouble. So when I say x, y, z, so the least significant, this one is the most significant, okay? So here we have actually, as I told you, we have 0, 0, 1, 1, 0, 0, 1. Oh, what I'm doing here? Okay, I'm sorry. We have here 0, 1, 0, 1, 0, 1, 0, 1, right? And then we have here 2 zeros, 2 ones, 2 zeros, 2 ones. And here we have 4 zeros, and here we have 4 ones. Is that okay? This is Now let's have f, function f, okay? Just for example, also I'm gonna put some random numbers, but just it can work for any other f, okay? So for example here, if here I'm gonna have, for example, here 1, then 0, 1, 0, 0, for example, 1, 1, 0, for example, okay? This function. So if I wanna represent this function in product of some format, number 1, okay, remember what I explained before, because I'm going to do some changes now. Number 1, I'm going to work on zeros, not ones. This is the first difference. So the first difference here, I'm going to work in zeros, not ones. Make sense? This is number 1. For every one of them, I'm going to have one term here. Okay. So here in this specific case, I need one term here from this 0, one term from this 0, one term from this 0, one term from this 0 here. So we're going to have OR here. So every term is going to have OR here. Okay. Okay. Again, before I tell you how can you do it, also I want to tell you the logic. How I'm going to design it. What is the logic? Which is exactly similar to the logic I did before, but now I need to consider the type of the gates I'm using, because these gates are different from the gates I used before. Look at the idea. Now I have AND here. AND is telling me, and tells me, if I want to get 0 here, please, at least one input is 0. If you want to get 0, at least one input is 0. Is that okay? So the way I'm going to design it is, for the term, for this term, when this is the specific input, I want this term to give me 0. And anywhere else, this term is going to give me 1. You got what I'm saying? So when this input comes, this term is going to give me here 0, so that I can get 0 at the output. Anything else, any other input, this term is going to give me 1. Okay? This is exactly the same thing I explained before, but I just changed the because I changed the gates. Okay, so same thing here. Here, when I do the term here, I have to make sure this term is going to give me 0 in this specific case. Anywhere else, give me 1. Okay, so this is exactly what happens. What happens when this input comes? The term gives me 0. I get 0. The others are going to give me 1. So I can have 0, 1, 1, 1, 1, 0. If this one comes, this term gives me 0. The other will get me once. I get 0. In this specific input, this term, okay, is going to give me 0. Others are ones, and so on. For any other inputs, all of them are going to give me once. 1, 1, 1. Why? Because I'm going to design this term so that in this specific case, it gives me 0, and any other case give me 1. But how can you do that? I'm going to tell you how you can do that. So the way we're going to do it here, okay, look here. So first of all, you have to use OR, because this is product of sum. So here, this term, it has to be OR. So I need to OR this one, okay? So here, in order, if I have OR here, in order to get 0 here, all inputs have to be zeros. All inputs have to be zeros in order to put 0, because here I'm using OR, because this is product of sum. Okay? Sum. This is sum, product of sum. Okay? So in this case, in order to get 0 here, any term that is 0, okay, I'm going to use the same term. So I'm going to say here X. Here, I'm going to say Y. But any term that is 1, I'm going to prime it, Z prime. X, Y, Z prime. Okay? If I use this way, X, Y, Z prime, or what's going to happen, think about it. In this specific case, I'm going to get 0. In any other case, I'm going to get 1. Okay? So again, so here, same thing for this one. Let's do this one. So this one actually is going to be X, any 0. Any 0 takes the same variable. Any one you need to complement it in order to get 0, 0, 0. Okay? So it's going to be X, Y prime, Z prime. For this one here, it's going to be X, okay, Y prime, Z prime. For this one here, it's going to be x prime, y prime, z prime. I'm right or I'm mistake? So now the final is f is equal the first term, okay, which is x or y or z. Oh, sorry, this is or. I'm really sorry, because this is product of sum. All of them have to be or. Okay, this is or. So now the final, I'm gonna take the first term here and with the second term, which x or y prime or z prime, okay, and okay, next term x or y prime or z prime, and okay, x prime or y prime or z prime. X prime or y prime or z prime, right? This one, last one here, or the one before? The one before should be x prime, y, z. Yeah, you are right. So this one, sorry, this one should be x prime, right? Anyone has to be 0, y and z. Yes, x prime, yeah, y and z for this one. Any questions? Again, so I'm going to show now example. Now I have two different representation to the function. Okay, both of them give you the same truth table. Both of them are okay. Okay, but one in the form of product of sum, the second one in sum of product. Okay, same thing as I just have explained right now. Okay, let me. This term is here. Okay, let me remove this ones first here. Okay, so this term is here, guys. We call them max terms. Max terms. Okay, remember the ones when I talk about sum of product, the ones I called them min terms, but this one max terms. Is that okay? So, and also similar to what I did before, I can represent the function in terms of max terms. How? Look here. This is row number 0, row number 1, row number 2, row number 3, 4, 5, 6, 7. So I can say my function f of x, y, z, okay, should equal to by, not summation, by of, look here, this term here is term number 1, term number 3, term number 4, term number 7. Okay, so when you see something, this is another way to represent the function. So I can represent the function using truth table, using equation x, y, z equation, or using something like that. So if you see something like that, I'm telling you in your function, your max terms are number 1, number 2, 3, number 4, and number 5. In other words, row number 1, 3, 4, 7, 1, 3, 4, 7 are actually these rows are zeros. What about the other rows are ones? I don't need to tell you, I just give you the zeros. Okay, but because we have only two options, 0 or 1s. So if I give you the zeros, that means the other ones are 1s. If I give you the 1s, it means the other ones are zeros. You got what I'm saying? That is why if I give you the min terms, it's very easy to convert to max terms. If I give you the max terms, it's very easy to convert to the min terms. How? I'm going to tell you how. For example, this is max terms. In other words, this is a location of zeros. So the same function, I can represent it this way, x, y, z. I can say equal summation. Summation means this is a location of ones. And this is sum of product. This is product of sums. Anyway, summation of what? Now, I know the zeros are at 1, 3, 4, 7. So the remaining ones should come here, the remaining ones, right? So here I can say, what I'm explaining right now, guys, if I give you the max terms, how can you give the min terms? Or I give you min terms, how can you give me the max terms? Very easy, right? Because one of them is going to tell you the location of ones, okay? The other numbers, okay, are going to be min terms. Same thing here. This is the max term. So the number I'm missing here, I'm going to put it here because this is the numbers of ones. Because I give you the location or the rows of zeros. So here, number 1, 0 is missing. So 0 has to be. And if you look here, yeah, that's true. 0 is here. 0 is 1. Okay. What else missing here? Number 2 is missing. Yeah. Number 2 is the location of 1. You can see it here. Okay. So we have 0, 0, 1, 2, 3, 4, 5 is missing, and 6 is missing as well. This is 5 and 6. Any questions? Is that difficult? So I'm going to give you more examples, okay? Okay, so for example, as an example here, I already here, for this truth table, I'm gonna work on the ones here, the main terms as I told you, and this is the function I got here, this one here. Okay. Next slide, I'm gonna use exactly same truth table, but this time I'm gonna work on the ones here. When I do that, I'm gonna get that's what I get here. Okay. So ABC, if you remember here, A, B, C, here, A, B, but anyone, I'm gonna make it prime. Here, A or B prime or C, this way. Okay. So now, look here, guys. This is a representation to this function. This is another representation to the same function. Okay? Both of them are going to give you the same result. So how I can, as I explained before, I give you two functions or two expressions. This is one expression. I have another expression here. How I can make sure these two expressions are equivalent? Because I told you both of them are the same function, but I represent it in a different way. That's it. Okay? How I can do that? You have one of two options. You can create the truth table of this one. You can create the truth table of the second one and see if they are gives the same results or not. You will find it possible. The other way, as I said before, you can do simplification, and that's exactly what this is the purpose of this slide. The purpose of this slide is, okay. Number one, I want to prove to you, okay, this is what I got from sum of product, okay? This is what I got from product of sum. Is that okay? So the purpose of this slide has two purposes. Number one, I want to convince you these two functions are equivalent, but I wrote it in different format, okay? So what I did simply, I just simplified, and I'm not going to explain how, because I already explained simplification before. You need to go through it to improve your skills in simplification. So I simplify this one, and I find this is equivalent to this one. Okay? I did the same thing here. I simplified using algebra manipulation, and I got this result. If you look at this result and this result, so actually they are equal. Conclusion: if you have a truth table, you can express the function in sum of product this way, or product of sum this way. Okay, both of them are equivalent, give you the same result. So this one is similar to this one. This is the first thing. Conclusion here. There is a second important conclusion. There is a second important conclusion. The way I explained right now, when I calculate the sum of product or product of sum, this is going to give you the function, not the simplified function. This is a different issue. It's not the simplified, right? It's going to give you a function for the truth table, but it's not the simplified one. If you want to simplify it, okay, so here this function, I got it from sum product or product of sum. This is going to give you a function. It's correct, but it's not simplified. Okay? If you want to, it may be by accident simplified, maybe by accident, but it's not necessarily to be simplified. That's what you should understand. Okay, so that is why if you want to simplify it, so you can use algebra manipulation as I did here in this slide, or as I'm going to explain in chapter 3, we're going to use maps, key maps, as I'm going to explain in chapter 3. This is another. So what you should learn here, sum of what is the meaning of sum of product, as you see here, okay? What is the meaning of product of sum, the format here. So actually, look here, sum of product is actually, if you see, when I implement this one, so this is one OR, but we have multiple AND. Is that okay? But that's why we call it AND OR format. It's two level. It's only two levels. So if I want to implement this one, it's only two levels, one level and then all of them are connected using OR. That's why we call it and OR. The other one here is actually one and, and for every term we have OR. That's why this format is called OR and. Any questions? And so now I want to, for sure, I'm going to give you more examples so that you can understand better. And you have so many examples in the slides here. But I want to answer a question. Now we have two formats. Why we have, which one I should use, or why I have two? Can I just use one and that's it, or sometimes it's better to use one of them? I'm gonna give you the answer. The answer, there are two reasons, okay, to have two formats. The first reason is, as I told you before, if you have and or, let me go back here in the slides. Yeah. So here, yeah, this is and or, okay? So and or is equivalent to NAND this way. So you can, that's what I explained last time, if you just do the simplification. So if you have a circuit like this one, and everything connected to OR, it's the same if I have NAND, everything connected to NAND. It's the same, gives you the same result, okay? This is the format of sum of product. Okay, so what I want to say is, if I want to implement the circuit using NAND, so I have to put it in some product format. Okay. So if I want to implement the circuit using only NAND gate, okay. So in this case, I have to put the function in some product format. Once you have some product format, so you can easily convert it to you can implement everything using only NAND. And this is actually, this is what they do in the chips. When they manufacture chips, it's easier, it's more efficient, it's even faster for them to implement using only one gate instead of using multiple gates. What I'm saying? So if you have a logic circuit, I can implement the logic circuit only using one gate, like NAND. Okay. What about product of sum? So if I go back here, I think it's coming here. Yeah, this is product of sum. Okay. In product of sum, as I told you, we have only one and, so it's OR and. One and then we have or. Every term has one or here. Every term has one or. Okay. So as I proved in this slide, if you have or and, actually it's equivalent to NOR. This one. Two levels of NOR and NOR. That means if you want to implement your circuit using NOR, okay, you have to use the format of this format, okay, which is product of sum. So the first, okay, before I take this question, so the first reason why we have two formats. The first reason is because one format can be implemented using only NAND gates. The other one can be implemented only using NOR gates. And it's up to you. If you want to do everything using NOR or AND, we have the two formats. There's another reason I'm going to explain it, but this is the first. Yes, you have a question here? Yeah. Which one? 57? Yeah. I said last, so here the inverter is not here, the inverter is on everything. And I corrected the slides and I'm gonna upload it, okay? I told you, yes, there is the inversion is not here, the inversion is corrected. And also I'm gonna correct the slides and I do it, okay? I'm gonna upload it, okay? Any questions? Okay, so what is the first reason why? So now what you should learn, given truth table, you should be able to calculate the function either using sum of product or product of sum. Also, you should understand sum of product. This one is used it can be implemented using only nan. Product of sum can be implemented only using NOR. And this is actually what usually we do, because when you manufacture a function using only one gate, it would be much better. Is that okay? This is one reason. There is a second reason why you have two formats. I'm going to show them to you, because sometimes one format is going to be much more simplified than the other one. So in this case, I can just use the other format. So let me, so for example here, I think I have one example here to explain this point here. Just give me 1 sec. Yeah, look, for example, look here, guys. For example, what if we have only one, the min term is only 0, and the max term is everything else. That means the function, what this means? I already told you. It means we have, in row number 0, we have 1. But in all other rows, we have zeros. Okay? In this case, you can find this one is going to be much more simpler than this one, right? Because this one has only one term, but this one has too many terms. Maybe this is also another case, unless you are going to do simplification for sure. If you do simplification, it would not matter. But this is also something you can take into account. If you have, because I told you, for every 0 or 1, for every 0, you have one term. For every 1, you have one term. So if you have, in this case, I have much more zeros than ones. Okay. So in this case, maybe it's better to use sum of product and product of sum. Okay. Any questions? Okay. Very important. Very important. This slide is very important. So now, if I want to represent a logic function, I can use a truth table. Okay. So you have to tell me x, y, z. You have to give me all options, and then you have to tell me when the function is 1 and when it is 0. The other way, you can put it here in this format, which is sum of product, or you can put it in this format, product of sum. So I can explain this way, sum of product of sum, or I can just represent the function using min terms or max terms. Summation 0, 0, 3. And here I have to tell you how many variables you have here. Same thing here, I have 2 variables this way, and then I tell you 1 or 2. Okay? So this is actually the locations of the ones. This is the location of the zeros. Okay? So if I have 1 at 0 and 3, that means the other column, the other rows, all of them are zeros. Because I only give the ones. Here I give you all of the zeros. Anyway, so let's see. I explained the main things I want to explain. So, but now, I think I explained, and I think this is one of the things you are going to do in the coming lab. It's about the propagation delay, how much the delay you will have. So, for example, if you have 2 level, like this one, 2 level, so the delay will be how the time here, the delay here, plus the delay here, right? Because all these gates are working at the same time. But in this case here, we always look for the longest path. So in this case, if you want to calculate the delay, 1, 2, 3. So it's going to be, we need, in order to get the final result, I have to wait until this gate is done, this gate is done, and this gate is done. Okay. So now, as I told you guys, here, these are row, this is row 0, row 1, row 2, row 3, row 4, 5, 6, 7. That's what I told you. Okay. Min terms, how can you get the min terms here? M0, M1, M2, M3, M4, and so on. Nothing is new. That's exactly what I explained to you. The way I'm going to calculate the min terms is I want to hit here one here. So any zero, you have to complement. Any one, I'm not going to complement. So here, this one is 1. I'm gonna take it like C. This is zeros. I'm gonna complement A and B. Nothing is new. This is just similar to what I explained, but I just calculated for all of them. Don't be confused. I'm not gonna calculate for all of them. I'm gonna calculate only for once. But just I did for all of them, just in case you have one anywhere. Okay, this is the way you have to calculate it. But we only calculate it for once. Here, we use uppercase here for max terms. So this is the max terms. Okay. This how can you calculate the max terms this way? As I told you before, I want to get zero out of this one. So if it's zero, I'm gonna keep it zero. I want to hit zero using OR, right? So if it is zero, I'm gonna hit zero. If it is one, I'm gonna use the complement. Okay, guys. So just this slide, but from this slide, you should be able for any row here, you should know how can you calculate the min terms and how can you calculate the max terms. I calculated for all of them, but be careful here because I want to teach you how you can calculate for all of them. But when you implement a function, I'm going to calculate the min terms for only once, not unless all of them are ones. You got what I'm saying? Same thing here. I'm going to calculate the max terms only for when the function is zero. Yes. Yes, yeah, that's what I'm saying. Yes. Here I calculated for all of them, okay? So that when you have a one here, this is how you can calculate it. If you have one here, I want to show you for any row, how can you calculate it? But in reality, based on the function, for example, if I have a function this way, 1, 0, 0, 1, 0, 0, 0, 0, for example, okay? So in this case, I need to calculate. I'm going to take this one. I'm going to take this one here, which is this one. And then for sure, I'm not going to take these ones, okay? But here, I just calculate for all of them, right? To show you how can you calculate for all of them. Same thing here for zeros. I'm going to take this one for 0. I'm going to take this one for 0, but I'm for sure I'm not going to take this one, okay? The other thing, as I told you, you can represent the function this way, or you can represent the function this way, okay? Or I can give you the function this way, okay? Very important. If I give you the min terms, it's very easy to get the max terms. If I give you the max terms, it's very easy to get the other one. Okay. Any questions? Okay. So here, let me see what question I'm asking here. So here I'm asking you, if you have here the min terms here, which is number 3, this is number 3 until 7. Okay, this is the min terms. So that means the max terms are actually from 0 until 2, this way. Okay, so I can represent the function this way or this way. This is in min terms, this is max terms. Usually, I'm gonna represent this way if I wanna calculate sum of product. Usually, I'm gonna do this way if I wanna calculate product of sum. Yeah, this is just a very straightforward example. Okay, just I bought a lot of examples. So here, because you have here 1, 1, 1. So here I need to get the min terms and then I OR them together. That's why we have summation here. So summation is like OR. Okay. So here you can check this example. You see how I calculated them here. I have just said. Same thing here. If I want to do the same function but in product of sum, here I'm gonna take the zeros as you see here. And here the reason I put pi here because pi means multiplication. Okay. Here multiplication means n. Again, it's not multiplication, it's just n. Okay. So here, this is the max term, everything ended together. Okay. Yeah. So here, as I told you, if you have the min terms, you can easily get the max terms and the opposite as well. But now, if I give you the min terms or max terms, it's easy to get the truth table, right? Very easy, because for example, here, if I tell you this is the function, this is my function, okay? How can you calculate the truth table out of this one? Very easy. I have A, B, C. I'm gonna put here A, B, C. Please don't switch it. Don't make it A here. No, A is here. And C is the least significant bit, okay? Then I'm gonna put all possible cases. And then, in row number 1. Remember, the first one is not number 1. Okay, so this is 0. So you can convert this one to a decimal. So in decimal, this is M0, and then the last one here is M7. So here you need to go in M1, which is here, M2 is here, M6 is here, put ones. In the other ones, just put zeros. So here I'm explaining, given this one, you should be able to get the truth table easily. Any questions? Okay. Here, another example, it's exactly same thing. If I give you the max terms, how can you put them here? Very easy. For example, if I tell you, if given this max min terms, you can get the max terms here, the missing ones, okay? And this means the max term number 0 and max term number 3 and max term number 4 and max term numbers and so on, okay? And then you can go to this location, you need to put zeros. Again, this is not simplified. Now we're not, you can simplify it later, but what you're gonna get here is not simplified, okay? You can do the simplification after you get the function. Any questions? So you know the meaning of min terms, max terms, and so on, okay? What I'm gonna explain now, if some we call expansion. I'm gonna do some algebra manipulation, so that if I give you a term, if I give you, for example, an equation like this one, and then I ask you to put it in min terms or max terms, okay? So we're gonna do very simple thing. I'm gonna do just manipulation, algebra manipulation to get the min terms and max terms. But wait a second. So this is, look here, guys, because this is a very important thing. This one is sum of product. Is that right? Yeah, this format is sum of product. Okay, but this one is not min terms. It's not in the min terms format. Why? Because in min terms format, I should have all variables. Here I have only 2, A and B. So this term, again, listen to me. Although this one sum of product, but it's not min terms, because in min terms, every term here should have the 3 variables. Okay, the 3 variables I have. So what I'm teaching in this slide, guys, given this one, how I can get an equivalent one this way, okay? But both of them are sum of product. But this one is not min terms. This one is min terms. So how I can using algebra manipulation, how I can transfer it from here to here, so that you can get 1, 3, 5, 6, 7 this way. I get the min terms. So let's see how can you do it. Okay, I finish, and then I'm gonna take your question. Look, it's very easy, just manipulation. So look how I'm gonna do it here, guys. Look here. This is AB, right? What is missing? C is missing, right? So I'm gonna say AB is equal to AB and C or C prime. I didn't do anything. Why? Because C or C prime is actually 1. I multiplied by 1. I end with 1. I didn't do anything. Just manipulation in order to introduce C, right? And then after that, I can do distribution. So this one is actually ABC or ABC prime. So this one is equivalent to these 2 terms. You know what I'm doing? It's somehow funny. I'm doing the opposite of simplification. So simplification means I give you these 2, and then you simplify to AB. Now I'm doing the opposite, right? Why I'm doing the opposite? Because given this equation, I want to get the min terms out of it. So any missing term, I have to move it. So again, how you made it, as you see here, you have AB, and then I multiplied by 1, or end with 1. When I say multiply means end, okay? End with 1. And then I do distribution. So this is actually the simplified version of this one, okay? But this is min terms, this is not min terms. Okay. Same thing for C. Look here, what I'm gonna do with this one here. What is missing? A is missing and B is missing, because it should have the 3 terms. So I'm gonna do it step by step. Let's first introduce A, as you see here. So I'm gonna multiply, this is C. C is equal to C times or N, A or A prime. I didn't do anything because this is just 1. C and 1 is 1, right? and then I do distribution. Once I do distribution, that's what I got. So this one is actually equivalent to this one. But I introduced A, right? Since same thing right now, are you done? No, I'm not done, because in min terms or max terms, you should have the 3 variables. Okay? Now I have only 2. One is missing. So now I'm going to take the first term here, put B or B prime. I didn't do anything. I just multiply by 1. Okay, same thing. The second term, B or B prime, and then do distribution. Okay. Finally, once I do, so now I started from this one, and then using this small trick, algebra trick, just multiply by 1, I was able to get this one. If you do simplification, you move from here to here. If I give you this one and I simplify, you can move it from here to here. So this is sum of product, this is sum of product, this is min terms, this is not min terms. Is that okay? What's your question? Yes. I know. Anyway, so any questions? Okay, now given these ones here, okay, guys, given this one, how I can come up with these numbers? Okay, how I can know EBC means 7 or whatever. Okay, as I told you before, here in the way we calculated them, guys, here. Yeah. So for example, here, in case of 1, how I calculated 1? I told you anyone that has a 1, because I wanna get a 1 out of it. I wanna get 1. So anyone without it, if it is 1, so I'm gonna put it without prime. Anything that is with 1, I'm gonna put it with prime. Okay. So here I explain. If you have 0, 0, 1, how can you make it z, y prime, x prime? Okay, can you do the opposite? Can you do the opposite? So if I give you z, y prime, x prime, can you get the number? So now I'm asking you to convert. I want to convert from number here input to midterm here. Now I want to do the opposite. I want to convert this one to number. Very easy. I'm going to do the opposite. If z here doesn't have a complement, so I'm gonna make it 1, and the other ones I'm gonna put them 0. So this one is equivalent to 0, 0, 1. You understand what I'm saying? That's exactly what I did here. So I took, yeah. So let's start, for example, here. This one here. This one actually, okay, it is actually number 7. Why? Because it's 1, 1, 1, give you 7. What about this one? It's actually 1, 1, 0. Any complement, so 0. Because this is the way. Maybe it's a little bit funny because I didn't certain way. Now I want to do the opposite, right? So what I did is, giving 1, 1, 0, I created EBC prime. Now I'm going to do the opposite. Okay. So here, if it is actually EBC prime, so this is 1, 1, 0. 1, 1, 0 is number 6. Okay, this one. For this one is actually 1, 0, 1. Okay, which is number 5, and so on. Any questions? Okay. Yeah, so here, just another example. I don't think I'm gonna explain it. I give you this one here, and I wanna here, this one has 4 variable, not 3, 4 variable, A, B, C, D, 4 variable, okay? Now, this is the simplified version. This is the min terms version. So similar to what I have just explained right now, you can just use the trick I have just used it in order to introduce other terms here, because I told you to be in min terms, all variables have to be here. All variables. It may happen as what happened right now is I find one term is already repeated. So I just removed them because it just repeated. It doesn't make any sense to put here 9 and 9. It doesn't make any sense. So if a term is repeated, so this term is repeated somewhere else. That's why I removed the same thing for this one. Because every number here cannot repeat. It doesn't make sense. Because I'm telling you the location of ones. So it's not to put 1, 9. So what happened here, because I found this term is repeated with another term, I removed it. This term is repeated, I just removed it. And then after that, as I told you, I took this one and then converted to a number. As I told you, any prime, just to put 0 in any prime. No prime, just to put 1, right? So after I did this one, I got these numbers here. Okay. Okay. Yeah, I think nothing is new. This is just another example here. I have this function. I did this what we call expansion. I expanded the function. Okay, so that I found some terms I repeated. So this one and this one is repeated. So I'm gonna only keep one of them. I find this one and this one is repeated. I just took one of them, and then this is a final function. So this is a simplified. Most of the time I give you this one and you need to simplify it. Okay, but now I'm doing the opposite, right? Because I want to get min terms, because the definition of min terms or max terms, the definition is every term should have all variables. Okay. And then I'm gonna convert this every term here. I'm gonna convert it to numbers so that I can get this one here. So what I'm saying, guys, is if you have this one, you should be able to get this one. If you have this one, you can go back and get this one. Okay. If you have a truth table, you should be able to get this one without simplification. If you simplify it, you will come here. If you have a truth table, you should be able to get this format for the function. Okay. Yeah, I think nothing is new here. Just I give you a lot of examples. So here, this is the ones are here. Yeah. So now I'm gonna repeat everything again, but for max terms. Okay, max terms. So for example, if I give you this one here, okay, and I wanna I'm gonna do some algebra manipulation similar to what I did before, but what I did before, it was for sum of product or for min terms. Now I'm gonna do it for max terms. Okay, you need to keep in mind, similar to what I explained before, these two expressions are actually product of sum. Product of sum. Okay, that's true. Both of them are. However, this one is not min terms. Sorry, max terms. This one here is in max terms. So now the question, similar to what I did before, the question is, given this one, how I can expand this one here. Again, I'm gonna do a trick. Look here. This is AB. What is missing? C is missing. So I'm gonna do this way. Or C and C prime. I didn't do anything because I added 0. C and C prime is 0. I just added 0. I didn't do anything. Okay. And then after that, I can make distribution. I can take these two. I distribute them this way. As I told you before, this is very confusing to students because we don't have this rule in normal algebra. Just want to remind you, if you have X or YZ, I can do this way, X or Y and X or Z. Okay, so that's exactly what I did. Assume this is X, I do the distribution. So now A or B is equivalent to these two. Okay, and this is max terms, this is not max terms. Okay, same thing for the other one, for C here, because it's just the C. So now I'm going to introduce A first, then after A. So C is equivalent to these two. Now I'm going to introduce B. So here, as you see here. So I find C is equivalent to all of that. I did expansion. If you do simplification, you move from here to here. Any questions? So once I did that, I find this equation here is equivalent to this equation here. So this but this is the simplified. If I move from here to here, I simplify. The next thing, similar to what we did before, given this one, how can you get a number here? Given this one, how can you know what is the number here? Given this one, how can you get the number? Okay, I'm gonna see how when I have a number, how I get this equation, and then you can do the opposite. So when I had this number before, yeah. Look here. So the way I did it before, look here, guys. When I had 0, 0, 0, okay, so this actually it was I want to hear X or Y or Z, as you see here. That means variable without complement, that means 0, 0, 0. I'm doing the opposite of what I did before. Here, 0, 1, 0. So any variable without complement, so it is actually 0 without complement. With complement, make it 1. And that's exactly what I'm going to do right now. Yeah. So here, you have here 0, 0, 0. Got it here. We have here 0, 0, 1, which is number 1. 0, 1, 0. Any complement, make it 1. Okay. See here 1, 0, 0, and so on. Okay. Any questions? Okay. Yeah. Just I give you here more example to understand how can we do this expansion. Just more example. Nothing is new here. Yeah. So here also this is another example. What I'm doing here, I give you this function f equal whatever, and then using this function, I created the truth table as you see here, and I created f. You can do that for sure. Given this function, I can create the truth table as you see here. After you, this is another approach, by the way. So listen to me. If I give you this function this way, and I ask you, what are the min terms? What are the max terms? Okay. So there are two ways. One way to do expansion, as I did here. Expansion, okay, as I did here. The other approach is when you take this one, you can create the truth table. Once you have the truth table, it's easy to get the min terms and max terms. Okay. So that's what I did. So I took this function, I created the truth table. Once I have the truth table, yeah. So here max term 0 is max term. Then that's okay. Yeah. Yeah, same thing here. I give you this function. I created the table, and then you can get the max terms. Max terms are here, min terms are here. Okay. Yeah, so here what I'm telling you here, just I want to make sure you fully understand it. Okay. I can represent a function in different ways. I can give you the function this way. This is one way to represent a function. I can give you a function this way. This is a second way to represent a function. I can give you the function this way. This is a third way to represent a function. I can give you the function this way, number 4. Okay, I can give it you here this way. This number 5. Also, sum of product. Here I didn't do sum of. I did here product of sum, but I didn't do sum of product. Okay, so again, what is very important, so I can represent the same function in different ways. Not only that, you can easily convert from one way to another. Based on what I explained here, given this one, you can easily get this one or get this one. Okay, you can get this one here. If you simplify it, this one, you're gonna get this one here. Any questions? Okay. So last thing I have here in this chapter, I'm gonna start chapter 3 in this time. The last thing I have here is something we call don't care. Okay, I don't care. So what don't care means? Okay, it's very interesting. Look here. As you know, when I define a function, I say when this is the input, the function should be giving me 1. This is the input, the function should give me 0. Function should give me 1, 0, 1. Sometimes I see x. Man, what are you saying? This is binary numbers. This is a digital. So it should be either 0 or 1. Okay. Sometimes here x here means I don't care. I don't care if this function is this give me 0 or 1. That's why I make it x. I don't care. Why you sometimes we do something? I'm gonna tell you very simple. If I have BCD number, okay, and I want to make a function to tell me if the BCD number is greater than 0 or not. Okay, you know BCD number, as I said before, this is a number from 0 to 9 represented in binary, in 4-bit binary. Is that okay? So here we have 4-bit here binary. Is that okay? And then I want to design a circuit function. This function should give me 0 or 1 to tell me if this number is greater than 3 or not. Is that okay? So here, BCD should be a number from 0 to 9. How many inputs you need? I need 4, right? However, these 4 inputs, I can give me numbers from 0 until 15. But I'm gonna only use until 9, from 0 to 9. But it has to be 4. Why? In order to get from 0, the input should be from 0 and 9. Three inputs are not enough. 3 inputs are gonna give me from 0 to 7, not 9. So in this case, I have to use 4, even if I'm gonna be limited from 0 to 9. So let me ask you a question. What if the input from 10 to 15? If the input here from 0 to 9, the output should tell me if it is greater than 3 or not. That's why here I put 1 and zeros. But if it is from 10 to 15, what should be the output? Don't care, because this input should not happen. Or even if it happens, the function give me, I don't care if you give me 0 or 1 because it doesn't make any sense. Okay? That's why if I represent it in a truth table, in this case, I'm gonna put x here. Okay, in this case, in the cases from 10 to 15, right? Because the function is not specified in this, or this input should not happen. Is that okay? So anyway, so I'm gonna explain this one next time again. But for now, just to close what I explained, I'm gonna explain it again. But okay, so you are telling us sometimes I want, when you put 1, that means for this input I want the function to give me 1. When you put 0, that means you want the function to give you 0 for this input. Okay? Sometimes for some inputs, this input should not come. Or in other words, I don't care. What is the output? I give you one example here. I don't care. In this case, I put x. Okay. However, the last thing, just 1 minute. The last thing here, however, so now, sometimes, okay, now x means I don't care if it's 0 or 1. Sometimes I have to care. Or why you have to care? I'm gonna tell you why. Because sometimes if I assume this one are zeros, I will be able to get the most simplified version function. Or sometimes if I put 1 here, okay, so I'm gonna get the most simplified one. So in other words, I'm gonna select this x in such a way to help me to simplify the function. Either 0 or 1s. Okay, yes, I don't care about them, but sometimes if I assume they are, I don't care means I don't care what is the output, if it's 0 or 1. But I have to be smart. If I select the zeros, I have to see which one is gonna help me to simplify the function more. Okay. Anyway, so I'm gonna talk about this next time, and then I'm gonna start chapter 3.